As a rule of thumb, you would think of your commits as like logical units of change. So you like when you are doing a feature, you divide this feature into a bunch of changes. For example, if you are adding a shopping cart to your website, right? You let's say you are like so you will not, of course, you will not do the front end and the back end in the same commit. You will not do the changes for the front end and the back end in the same commit. You should not do that. That's very bad. You should separate. This is the like first separation layer. You should separate front end and back end into two separate commits. And I would say go even further into looking into the front end part. So let's say you are adding the routers, and then you are adding the components, and then yeah, whatever. So you separate your commits into commit to add the router, then commit to add the components, and then maybe commit to integrate them or whatever. And then in the back end, you do the same. Commit to add the route in the back end, commit to add the implementation of the route, commit to add the changes you would add to the database and stuff like that.
But like also is I'm changing the branch, do all the changing stuff like backend, frontend, after committed all the code file.
Like on the same branch, split your commits in.
Yeah, so for example, I created the component,
Yeah.
finishes, commit.
Yes.
Create a new one, commit again.
Yes, exactly.
After I'm pushing all changes.
Exactly.
What if you start to do something and I understood that my backend or Node.js source doesn't work, so I go to the Node.js source, try to change it, and then go check how it works. So how should I do this way? Because we work together, so I couldn't divide it. That's what yeah.
So basically, if your commits have a change, let's split this question. First of all, if you do a change and then you want to commit it, but your application does not build, that means that your change is not complete. You can make the change until it builds and then commit it. But for example, the deepest example, you would add a component and then add a component, then your application builds, so fine, you commit this component. You don't add two components, for example, in the same commit. Because you add a component, application builds, add a second component, application builds, commits, and so on and so forth. If you want to go back and change a commit in the middle, there is a command called attributions. We are going to go through the topic of rebates in this session, hopefully, if you have time. And I will talk a little bit about interactive rebates. I like this. That's not me, right? That's not me. That's me, actually. Yeah, that's me. Yeah, yeah. That's me.
On the backend side, we can check it before.
Can you say again?
Backend, we can check it where it's working enforcement.
Yeah, you can do that. You can define, like, for example, for me, yeah, I would say build and working.
It's also easier to debug because if the application doesn't build, fail somewhere, it actually narrow down to a commit. Like you can, instead of looking all the changes that you did, you just go to a specific commit. Okay, this section here is not working, so you can go into that commit and see what actually what broke and what's not working.
Exactly. Yeah, like just doing Control S in your application, but on a Git level. So you can also go back if you find a component that you don't want anymore. Like management said, we don't want this component anymore. Now you can go back to the commit where you did this exact specific component and remove this commit only, instead of like if you have your like all of the changes in one commit. What are you going to do in this case? Are you going to revert the whole changes and then pick up the changes that are relevant now or are you, or is it easier to just go to this specific commit where you added the component and then just revert this one? So
How we do that? It's
interactive rebase. We are gonna talk a little bit about interactive rebase. So in this, currently what I want to do is again revert commit B. So I want to take the SHA or the commit ID for commit B and then say git revert, git please do revert this commit, right? And then if I press enter, it opens this. So git already reverted the commit, and now it's going to commit it. So it opens this editor for me to change the commit message if I want to change the commit message. But I don't want to change anything. So I just type in column WQ and then force. And now if I go to git log, I can see that the last commit is basically reverting commit B, right? Now, if I ask git, please show me what exists in this last commit, I would say git show, and then it says, okay, we removed exactly what we did when we revert the commit manually, and we can see that if we also go back again and say git show the commit B, which is basically the inverse. So yeah. So in the last commit, we removed Lamborghini, we removed Bentley, we added Porsche, but in the first commit, the one we wanted to revert, we Porsche and added Lamborghini and Bentley, which is like, you know, the inverse of the commit. So that's basically a reset. That's, sorry, basically revert. What we want to talk about for, yeah.
But you are working for a lot of these.
Mhm.
Someone do what special doing what or yeah, pushing.
Yeah. I'm doing it in my own branch. I would revert changes in my own branch. You should not. So if it's a branch like main where everyone is working on this branch, the decision for revert has to be taken seriously. If you are trying to revert the commits that exist only, unless you are of course the owner of the commit. Maybe in this case it's okay, but if you are working a change or on a branch that you are not the only one working on this branch, then and you know for a fact that this commit may contain more than your changes, then you have to like not revert unless you like everyone agrees you need to revert it.
What if like 50% things are so I don't want to revert all of them something that how does that work?
So there is an option where you tell git, so git revert, but do not commit. And in this case, git will revert the whole commit. And then you go, for example, open Visual Studio Code and go through the changes one by one, choose which changes to stay and commit, and which changes to not commit. So if we type git revert, it's gonna be even like yeah, it's gonna be the same, but it's gonna be even better than this because you're gonna use Visual Studio Code as the UI to say which changes to stay and which not to stay.
Oh, highlight.
You will have so you will have the commits appearing in this part. You will have all of the files that were changes appearing in this section, and then you go through every file, and then say, okay, I want this. Like right click and then add, or change the file and then git add the file. So that's how you can like revert a commit completely, but pick up the changes to not no, not git revert all commits. It's called so it's git revert as well, but there is an option to no commit. Yes. So automatically the command will create a commit for you at the end. So what I did was git revert help, and then it opened for me this web page for me to read the help. This is like what exactly, this is a detailed description of what git revert does and what are the options that git revert accepts. The only one option that we might care about is this no commit, or you can either say dash n or no commit. They are both basically both the same. And then it says that usually the command automatically creates some commits with the commit log message. Blah blah blah. This flag applies that change necessarily revert the name commits to increase but does not make the commits, which means it will revert but does not make the commit.
What if I revert the wrong?
So if you revert the wrong commit, then you revert the commit that was the wrong commit reverted, and then you revert the other commit again. Or you can just you can deal with this with interactive rebase. Rebase. We are going to talk about it. So yeah.
Can you focus?
Yeah. So let's say we want. So now if we go to git log, we have this commit B that's revert, but we have also commit C. Let's try and revert this commit, right? And if you remember in commit C, we added a file with the fruits. If we do git show paste, it says here new file mode. That means we added file 2.txt, and then what was in file 2.txt is grapes, banana, tomato. Okay, and then what we want to do is git revert no commits, and then the commit we want to revert. So now if you remember, so can you see here main, we are on branch main, but we are also going through a revert. If I did git status, it will tell me this file 2.txt is deleted. That's the change that we want to commit, right? Because in the commit, we only added file 2.txt, right? So the inverse of adding file 2.txt is to delete file 2.txt, right? So that's the, it also says a bunch of, here in this section, part we are more concerned about, you are currently reverting commit, and then gives me the commit ID. All conflicts fixed. We don't have any conflicts. By the way, you can create conflicts when you do git revert, and in this case, you have to go and fix the conflict manually. And we are also going to talk about conflict resolution. If you, so all conflicts fixed, we can run git revert that continue, or use git revert that skip to skip this revert, which basically will do nothing. Like it will be as if we didn't actually revert anything. Or we do git revert, which is will be kind of the same, but in case you are reverting multiple commits in the same patch, you can say I want to revert this commit, this commit, this commit, this commit. You might the difference between skip and port in this case is that if you say skip, you will skip the current commit that's being reverted, and then you will go to the next commit that you want to revert to check. Or abort will abort the whole revert process. But the point from what I want to say is, if you read git status messages, you are going to figure out what you need to do next. It's not like you are gonna be lost and not knowing what you want to do. But let's go back to Visual Studio Code and see here. It says that this file is deleted now, and this file contains these changes. We are okay with these changes happening. Now we say git revert -- continue, and then I press enter. It now again opens editor. to allow me to change commit message. I don't want to change the commit message. Actually, let's change the commit message. Just do it. So let's say this is commit E. What I did basically was press I to insert, and then I press ESC or escape button, and then colon WQ, and then this exclamation mark. If I do git log, I have this commit, like the top commit, that's commit C or commit, that's the reverted commit C, or what I call commit E. We have revert E, we have C, we have P, and then if we go down a little bit more, we have commit A. That's the first, that's my laptop, sorry.
Opposite of the
Commit B is the opposite of revert B. Commit A is the initial commit. We didn't touch this commit, but we can revert it as well if you want. But that's like,
but it just goes from the last to
so yeah, from the last latest to the earliest. Yeah, so it goes on like a timeline basically, you know, like on Facebook timeline. Posts appear from the last post that you made to the first post that you made. So that's the same. Cool. So that's revert. Yeah.
one say that when you are working with each component,
Mhm.
let's say I bought this component, I finish, then I put, and then I remember that I need to add type to it. Do I have to do something from it or the way that?
There's a way you can modify this commit, but this is also covered. This is Git interactive rebase. And we will go through the interactive rebase when we talk about merge and rebase. Like what's the difference between merge and rebase? Okay.
But practice like making out engine again, you need to
It actually it depends. It depends on the team style working that you are working with. So for example, we are also going to talk about how to work in a team using Git. But there are teams that are okay with, instead of like going back to the commit and modifying it, you can just create a new commit with the changes that you want in the component, and that's it.
It's more convenient.
It's more convenient, but also it depends on how you are going to merge your branch back into the master branch. So, for example, when we are also going to talk about merging, you guys are very, very, very like curious about merging rebase, like all of the questions we get involved with this topic. So, can you like memorize the question and then ask it when we talk about merging rebase? Because yeah, I'm going to explain a little bit more. So, yeah.
So sometimes it goes in visual studio like a million or no file, or I don't know, on the same branch accidentally there is some file which is not connected. But when you for the start and when you go to the start, it seems like it is where I go. It is so confusing. I don't understand where do you do it from this branch, from somewhere else, or from the whole existing.
You are working on a branch, so that's why we work on branches in this. That's why we use branch to isolate our changes from the master branch or from the main branch that we have. So the main branch should ideally be always buildable. That means if someone goes and builds the main branch, it will always succeed. Always be working correctly. So because like when someone deploys the main branch in production, they have to deploy something that's working, right? That's definitely working. So that's why we take a branch from the main branch, do all of the changes that we want to do, and then commit them in the branch and open a pull request and move back to the main branch. To make an approval for everyone to make. Yes. to make sure that our changes will not break the main branch. So the main branch is broken, then that's bad. That's bad for the application. So always keep your main branch succeeding, like buildable and like working correctly.
And also, one thing about the main branch in production environment, the main branch is usually protected, which means you cannot commit directly to the main. If you try to commit directly to the main branch, it will be rejected.
No, I think it means,
To prevent, bad code going to the main branch instead of the.
this commits, I'm not the main branch, it's my local branch, but anyway, I still wonder, like, if I describe them, will they be present on my computer, but not on this desk, but on my computer, if I work, not in Visual Studio Code, if I just open the folder, tomorrow.
So we are also going to talk about Git stash, and when this happens to me, I do Git stash. I stash all of the changes, and then do Git stash apply. That means they exist in the stash just as safe changes, and also now they exist as changes that I'm ready to commit. And then I go through the changes one by one, see what to keep and what to remove, and then do this selection and commit. But if you are reverting or doing some changes and you have thousands of files, that means you did something wrong. Something happened that's wrong in the either you have a commit with very big like number of files that you are converting, and in this case it's strong to have many commits, many changes in the same commit. That's the wrong thing. Or you are changing commits more than you should. You are reverting lots of commits more than you should. Thank you.
This stash needs to be this, of course, in this branch where. Not.
No. Git stash, you can do it from any place.
Just from the terminal.
Yeah. So Git reset. So let's say you have this as your master branch. Okay, so you have Git A, Git B, and so on. And you want to reset, like, just keep these 3 commits and ignore the last 2 commits. That's where you can use git revert to say git revert P and then git revert P. But this will create 2 more commits here. That's the revert to commit P and revert to commit E. But we don't want to do that. We just want from the end of the timeline that's here, we want to go back in time, right? We want to just as if these 2 commits didn't happen. I told you before, you can just go to a commit in the history and remove it, right? This statement is true unless it's like the end of the timeline. Commits at the end, because this commit depends on this commit, right? And this commit depends on this commit. But if we remove these 2 commits, that's totally fine, because now nothing depends on this commit, and that's okay. Like the history is not broken, nothing's happening, everything is intact. So to do this, we can use git reset, which basically will undo changes from the end of the timeline. It will be as if nothing happened. So let's say now we have git log, right? We do git log, and then we have revert. Let's say, oh, we don't want to revert the commits anymore. We want to undo like these last 2 commits. So if I want to, so let's say that commit D and commit E are the revert of commit B and revert of commit C. We want to undo this revert, we would use git reset. And we want to stop at commit C, right? we want to reset the timeline all the way until commit C, right? So we will pick the ID of this commit to be the point where the reset will stop. So if you say git resets, now let's we are losing the changes that happened in commit D and commit D in this case. Yeah. But there are options to provide to git reset to not lose the changes, but they will not be committed. They will be as if you did a change and you need to commit git commit to do the changes. So in our repo, this is commit E, right? And this is commit D. So we want to stop at commit C. We take the ID of commit C, copy, and then do git reset. Do this all the way up until this commit. So there are two options you can provide to git reset. That's git reset hard and git reset soft. Git reset hard will remove the commits and discard the changes. The changes are gone completely. And git reset soft will remove the commits and make the changes like ready for you to commit or discard if you want to. Is this clear? For now, I want to do git reset soft just to show you. And now if I do git status, so basically what we did in commit D was to modify file1.txt, and what we did in commit E was to delete file.txt. And now the commits don't exist anymore in the history. So if I did git log, now we only have commit A, B, and C. All of the revert commits are gone, right? And we have the changes that we did in the revert commit. So if I go to Visual Studio Code, so basically the changes that we have, if you remember at commit C, we removed these two and added Porsche. Now we are at commit C, and in commit D, in commit B, sorry, in commit that happened in commit B, and commit C, we added only a file text. We removed it in the revert commit, so now it's added back again. So yeah. Yeah. So because reverted changes are just commits. So you can revert to commit anyway, whatever this commit is. So now if I did, now we did git status, and we have these changes. Depends on what I want to do with these changes. I want to discard them, so I'll just say git restore staged file1.txt, file2.txt. And then if I did git status again, I can say git restore file1.txt, file2.txt, and now all of the changes are gone, and I have a clean branch with just these three commits, A, B, and C. Any questions about reset?
Because I saw you have commit.
So reset does not commit anything. Reset just takes the commit out of the history and then gives you the changes that happened in these commits. And then you have the option to commit or discard. So that's reset. I discarded it. If I want to do that from the beginning, I would just say git reset and then like this, git reset -- hard, and then provide the same commit ID, that's commit C, and then it will do the exact same thing. Just with one commit. I only went like the soft way just to show you what happens with git reset.
So if it's soft, so we should run reset soft, and then I do the commit, and then discard the changes in the file name.
Or like Sounds like a good idea. Okay, so any questions about revert and reset so far? Okay, so moving on to stash. And stash is just a way where you can save your changes without committing them. So let's say you are working on a feature, and then you had a previous feature committed from the name, and you have your changes currently while you're working on this new feature. Someone comes to you and says, hey, there's a bug for the first feature, you need to exclude it. So you need to do the check out, right? You need to check out, for example, the first feature, right? Solve the feature in 9 minutes, or maybe create a fixed branch, and then do the fixes and then do this. In this case, what do you want to do with, like, you are halfway into the feature and you want to keep your changes, but you also don't want to commit them. So this is where git stash comes into play. And by git stash, so let's say now we have commit C and commit D. Let's say I want to add file 3.txt. And what do you want to add in this file? Cakes, okay. Cookies, pancakes, yeah. Cupcakes, yeah. It's my favorite. And now suddenly I want to check out of this branch. I don't want to commit my changes and I want to check out of this branch. If I did git status, I have this file 3.txt and I don't want to lose the changes. So what I would do is basically type in git stash. Is my screen like clear, or should I zoom in more? Okay, I'll zoom in more. So I do git stash, and that's it. Okay, sorry. Huh? So if you check out, so let's say you are creating a you will not lose anything, but the changes will come with you to a new branch that you created. You don't want that. You want to work on a clean branch to do the fix, right? Okay.
They always come with that.
Yes.
But can you from the state or
That's what happened when I said git stash. And it says no local changes to save because it's not staged. It does not see that. Exactly. That's correct. So I need to do git add -- all, and instead of git commit, I would do git stash. And then it says, okay, so save working directly and blah, 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 something. So that means that my stash is, like, my changes are saved and they are gone actually now, like nothing exists. Here, my working tree is clean, my repository is clean, and my changes exist in the stash. So without committing, actually. Maybe you don't want to commit them. Maybe like the changes are not complete, they break the build, or you just don't want to commit them for whatever reason that exists
Maybe
in the world of software.
key, maybe just trying something and not
But
sure.
they're not skillful. So everyone is a job role.
You are not you're not done with the changes. You have to make it literally to the point where you want to open a pull request. You are just like halfway in the implementation, but it's actually broken.
It's stash if you like, if you work with like Word, it's like you're creating a draft. And you're saving that draft for later. For you to revisit later. That's what big stash is.
Yeah, exactly. Cool. And then I want to, okay, so now that my changes are stashed, I want to see my stash, like what exists in my stash. I would say git stash lists, if I remember correctly. Yes. And then it says to me, this is stash number 0. This is the first stash I created. It's a work in progress. It was created when I was in branch main. And this is the commit, the head commit made, like the last commit. We don't care about this. We just care that, okay, we have one stash. I want to know what exists in this stash, like what are the changes in this stash. If I have a commit, what would I type? If I want to see the changes in the commit, what command, which command would I use? That's to know the commit, but I have a commit ID and I want to know what changed in this commit. Yes, git show, right? So I would say, instead of git show directly, I would say git, or actually, I think we can say git show directly, if I'm not mistaken, and then say, okay, git show, see the first stash. I don't know if this will work or not. It just shows the like the information about the stash, but I want to see the stash changes themselves. Okay, so if I say git stash show stash at 0, it says, okay, so you have file3.txt with 4 insertions and just yeah, 1 file changed and 4 insertions. So Git, when you stash things, Git does not give it an ID like commit, gives it stash at 0, stash at 1, stash at 2, stash at 3, and so on.
Have a few dash.
No, you can stash whatever you want.
Yeah, but like before I multiply. Should I make one more stash from the another?
Yeah.
Okay, so it could be 5 dash.
Yeah.
Dash.
Stashes, yeah. Yes. So just to show this part, let me create another change. Maybe so now file3.txt is gone. I want to add lettuce in the file2.txt. Actually, we are saying fruits, so it's fruits. Okay. Yeah. Tomato is a fruit, but I don't know if do they contain seeds. I don't think they contain seeds. So yeah. Apple.
Orange, but tomato and watermelon berries.
That's the only halal dates we know. So I'm sorry. Someone was saying something. Peppers. Okay.
Berries, tomato probably.
We had enough. So I would say git add dash dash all and then git stash. By the way, you can provide a message when you do a stash. And then it will be with the same way you would provide a message in the commit. My second stash. And then it saved my stash. Can you remember the command to show all of the stashes that we have? They are done.
Yeah, this stash show.
Let's, I want to see all of the stashes. Yeah, they are gone. Yeah. Yeah, they don't exist anymore. And then I do git stash list. Now we have 2 stashes. So just because, so the stash concept is a stack. You know what's a stack? So what's a stack? Yes. Like you insert stuff in the stack, and when you remove stuff from the stack, you remove the thing on the top. You don't remove from the bottom. Yes, the first element of the stack is the element on the top, which is the element that was last inserted. So that's the stack. There's also another data structure, but this is not a topic, but let's just say for information, that's called the queue. And in a queue, you insert stuff and you remove the first item that you inserted at the first. So insert, like, for example, 1, 2, 3, and then you remove 1. And then you remove it, and then you remove 2. In stack, you insert 1, 2, 3, you remove 3, you remove 2, and then you remove 1.
There are two terms it's used for those two. One is LIFO, the other one is
FIFO.
FIFO, yeah. LIFO is this set, last in, first out.
Yes. Okay, so now our the top element in the stack became my second stack, the one that we just did, and that's the top element. And then the first element, just at the bottom of the stack, is the first stash that we did, which was stash 0. Now it became stash 1, and our last element that we inserted became stash 0, right? Cool. Now I want to get my changes back from the stash. I'm done with the hotfix. It's merged, fixed everything. Yeah.
Online and weekend. So
That's because this message is something because I didn't provide a message, so GIT automatically creates this template. But in the second one, I created a message. So GIT said, okay, I'm not going to create a template. I'm going to use the message that you provided to me. Any questions? No. Stack. That's a stack. You can pick any stash, but you have to explicitly say, I want this stash item. But with stash, you can just say git stash pop. And this will by default paste this and apply. But I can say git stash pop stash at 1, which will pop this element instead. But if I don't provide anything, it will pop the last element by default. Yeah. Yeah. If I didn't, if like we can test this. We can test this by maybe watermelon again. And then git add. Yeah, so I created another stash. That was the changes I just did. It used the same template as this one, and it became stash 0, and my other stashes were pushed down the stack. It's a good idea to provide a message, just because these two changes, it's not obvious what exactly happened in this one and what exactly happened in this one. I don't know. So it's a good idea to always provide a message when you do a stash. That's a template that's generated by Git, since I didn't provide any messages. Okay, so now I want to restore one of my stashes. There are two commands that I can use to restore my stashes. You can always find all of these commands and what they do. If you type git stash help, it will open this web page. Will tell you exactly stash that changes in a directory, working directory away. It will tell you what stash does, give you a description, and give you a list of, like, we call this synoptics or optional flags that you can use with stash to make it work the way you want. So there is a command here. I can see the two commands that are pop and apply. So pop will remove single stash state from the stash list. So if I say git stash pop, it will take the stash, remove it from the stash, and add it to the current working directory as the changes that I need to commit. If I use apply, it will take the stash elements, but leave it in the stash list and apply it on my current working directory.
keep,
It will keep it in the stash.
okay, but so should we keep the property in the stash or not?
Depends on what you want to do. If you want to remove the stash element, you don't care about it anymore, you just remove it. You just say pop.
Apply. And apply this, so it's this stash still will be in the
Yes, if you say git apply, it will still exist in the list. If you say pop, it will not exist in the list anymore. Any questions?
I need to make a I need to make a decision before commit because I can also ask me then to do it or otherwise apply.
Like if you say apply, it will exist in the stack, and then they will exist in the like they will exist for you to commit them in the current working directory. When I say the current working directory, I say the repository that and the changes that you are doing on the repository, the ones that after which you say git add and git commit. That's a working directory. So now
Are the same, then apply and commit are the same.
no. Apply just takes it from the stash and put it in your working directory, but keeps it in the stash. It does not commit it. You need to commit it or restore or do whatever you want. It's just like, so think of stash as commit, but in a separate word, basically.
It's still in my document.
It's still in the stash and your drafts, basically, and exists also on your working directory.
So yeah, if I have HTML document, so hello world, stash, now I need what for apply, right? And if I don't open, don't apply, that's for me.
Nothing will exist in your working directory.
Those kids can see. Yeah. While it's in the draft.
Yes, Git cannot see it while it's in the.
So you have to remove. Yeah, it's applied, and after it, you will see the changes, and after you will edit.
Exactly.
So, and so if you have a slash, you can commit.
Yeah, you can't commit it directly. If you commit stash as you.
So it means like, I'm not sure if this final code is correct, but I still want to keep it instead of copying control C, control V. No, I can do this and do disappear from working space. And I do the stash, but if I want to work, then I can delete forever or apply and then apply it will come back to that.
Exactly. Exactly. That's exactly. Okay, can you explain to them?
Yeah, so like, for example, when you did something, you have another option found, stack flow, like another solution. You want to try it, if you're not sure which one will, you don't want to use it. Can commit just. You can just, the one that you don't want to do, you can just make the stash code, and then you can try a new one. And then if it doesn't work, you can come back to the stash and restore it.
But when the file,
Apply.
Yeah. Oh, and if you delete it forever, if you apply, then it appears in your file, and then you can commit it and it up to it add.
but how it's usually in the code. You have, for example, one function that works with one, try another one, on Stack Overflow, first one we put in the stash, and try the second one. But in this code, we can see that both.
No,
You can see there's an option. I mean, I stopped using VS Code for a while now. There's an option on VS Code where you there's a tab there that you can see the stash. Yeah, the stash.
Yeah, so when you put in this function in stash, it just disappears.
It disappears from whatever you're working on, whatever file you're working on. Okay? You make hundreds of changes.
Okay.
Right? You're not sure. You just go and stash those changes. Right? So now your directory is clean. It's nothing. It's like if you just pull the branch and there's nothing on it. Right? And then you can start either working again on it, right? And you're not sure, try some other solutions, right? And if you're also not sure, you can also stash that one too.
Yeah.
Keep going that way. And then if you want to go, okay, I want to go to my previous solution, the one that I stashed before. Then you can go to the stash list and you can, if you're sure, right? Then the option is yours. If you're sure that solution is the best solution, you can pause from the stash, which means you're taking out from the stash and you were going to work on it. But remember, if you use pop, now that stash item, it's no longer on the stash list. If you commit and you push it, that stash is not gonna be there anymore. But if you apply, that means, yeah, you're gonna try that one, you know, if you want, it's still on the stash. You can go back to it later if you want to.
And to decide which one you want to try, you choose the in.
Yeah, if you, let's say you have like you try five different solutions for the same item, right? So you have 5 things that you stash.
Yeah.
You can apply each one individually. You go take that one, apply, and you go to the next one, that didn't work. You go to the next one, apply, and then, you know, as long as you're applying, you still have them saved on the stash list.
Okay.
As soon as you use pop, that change, it's out of this stash list.
And one more question for you people working. Do you use this stash a lot of?
I have stash like whenever.
I'm thinking of like removing my repository and cloning again just because the list of the stash is making it like wicked.
Keep your stash empty or like finish with the project. If they don't stash or don't just keep them or forget and just.
You can do it better, like, depends on what's your, like, you want to keep the stash list for any future references, you can keep it.
And this stash list, it's really just, you know, all the for the stash thing, one of the things was to do the file. When you stash the changes. So that's file be restored one of.
The way I usually use stash like this, I go and I change it because, you know, like in a real environment, you're working on a new branch, a new feature, and then you have some pull requests that are open. Then you have to resolve some comments from the pull request. So whatever I'm working on, I stash it. Then I go back, go to the other branch that I need to resolve some comments. Then I work on that one, finish that one. Once whatever I'm working on, right? Once that one is merged to develop and merged to test, because, you know, we have developed, test, and make. Once that merged, that goes into production, then I know that you have the commits that went into production, you can go into the stash because you know the code for everything. That's the way I do it. Because now I don't need the stash anymore because the code is on production, so I can go and see whatever changes that was there.
Perfect.
So let's say so the changes you know when you done the will they be combined with the revisions?
Yeah.
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 And the state when they branches specific, you know, they
No, it's per repository, not per branch. So you can stash something while you're on the branch and then go to another branch and then pop the item from the stash. That's also a way to move changes while you are on a branch to another branch, if you can check out. But since the from Mima's question, since it's gonna be applied to the current changes, you might get conflicts. So you might also, when you are doing a stash pop or a stash apply, need to resolve conflicts. Okay.
There's a folder that's usually hidden that you cannot see in every repo. And the folder is like, it starts with a dot, it's like dot git. That's actually the entire history of that repository. That could be clone a repository, that folder comes with you, for that repo. And that's usually you don't see it because it's a hidden folder, but everything that you do on that repo and anyone gets recorded on that folder. But it's not a folder that you should be looking at.
Yeah.
Yeah, don't go on that.
No, per repository. You can't have multiple. Yes, in the very first directory of the repository, it will exist the .git, and if you have multiple .gits inside the same repository, that's called submodules in Git, but that's a very advanced topic. We don't want to. We will not need that. You can have multiple .gits in the same repository, but we don't need that. We should not do that. That's like deleting the operating system.
If you actually go clone a repo from any repo from GitHub, then you see that folder, right? And so the hidden folder, if you delete that one, and then you try to do anything, try to git add, try to do any git command on it, it will tell you this is not a git repository.
Wow.
Yeah. In it, yes.
And is it in this Git folder from all the ground, commits from all the people?
I think that's what done the project gets important there. But that's not the topic of the class, but it was just for you guys to, if you ever see something, like if you happen to see that folder, don't touch it.
Okay.
I think I write command campaign how it create its folder. It's new folder.
No, that actually. But usually, if you clone the project from GitHub, that folder comes with you.
You're asking what's the difference between fork and clone? So fork normally happens at the most part in GitHub only. You don't want like fork basically says take this repository and give it to me as if I'm the one creating the repository and I'm the one. And it like takes the whole history, takes everything and just changes your version of the repository for you to be the one. It stops. It does not follow or track the original repository unless you say specifically pull changes from the original repository. So you have, in this case, you have 3 copies of the repository. You have original repository that was, for example, the Nikita's repository, and then you have your version of the repository on GitHub. That is all this on GitHub. That's that's on GitHub. That's not locally yet. So you the third one is local, yes. The last one is your local version of your own repository. Yeah, in your computer. Clone just like gets the remote part of the repository locally and then keeps track of the remote repository so that if any changes happen on the remote, you can pull them or you can push them to the fork. So if we have
like when I fork,
so let's think of it like this. Fork is like clone, but for the remote part, on GitHub. So if you want to clone Nikita's repository on GitHub, not on your local machine, you would go to Nikita's repository. And then this will clone your Nikita's repository to your GitHub account.
And I still on one computer I work and on one I go. I still can go to like US Gold, copy the address of the phone, play
your port repository, you can clone it on your local.
But, clone, I don't know. I mean, if I need to work with Logan, for example, create it on the branch.
If you have a local clone from the remote repository,
Yeah.
you can then create a branch and do whatever you want. Your local clone.
But then on GitHub, if I want to see, then I go to someone's account, and found the repository, it will not be on my account.
You will not see the branch you made on the GIT2 repository. In your own.
Selling group chat, so we fork the repository data create. So use some Georgia. But when we did pull request to own repository, it automatically. Yeah, in our.
You can pick which target for your pull request.
So if I. Already main,
You say, so in this case, your repository will be upstream, not origin. So
so if I give to origin, so that means that I have pull directed.
your, if you say upstream, that's the upstream part. If I understand correctly.
No, it's actually the other way around. So you have the selling group. This like you force all this to your account here, and this is right? So you fork it, right? So when you fork it, and then you go and then you pull this to your. So what you try to do is you try to create a pull request to where do you want to make a pull request? You want to make a pull request to this one, or you want to make a pull request to that one?
We try to make it's both.
You go to tell me that means that you are working on this one on the local team, or this you are on your phone here that you phone on. When you call this to your machine, you have to set your stream and the origin, because when you pull like I did this
Yeah, so this is the origin, and this is the upstream.
yeah, well, when he clones, this one, when he clones here, this is actually origin.
The origin.
Yeah, yeah. And then he has to set this one of here. Okay.
We just not and we just pull to origin, it's all directly down.
Yeah, because here on yours here, the origin is set to this one. Yeah.
How can you change that?
You have to do a deep remove dash B. That's going to list where the repo is coming from, where your local repo is coming from. Either we'll see two things. Origin in the URL that's in here will determine if it's your local or if it's this one here. Then you have to if this one here, if the origin is actually this one, then you have to set this one to one, and you have to set this one to. Which means you have to do a git set URL origin and that URL. It's a little bit
The last one, it's set.
what's that command again? It's git set.
Git set URL
Yeah,
and
git
then you
remove
put-
set dash URL. When you actually go on your, if you go into the repo now, you can just go in the terminal and just do just remote that, and you will see what the repo that you're working on.
Yeah, I'm cloning a repository that I forked, basically Elasticsearch, but this is gonna take a while.
So when it was the someone's repository,
Yeah.
it's sometimes allowing the for this virtual app, and it would ask me for some key information because it need to be authorized with virtual app.
Yeah, that's because you have people from some other person or organization, right? You don't have the authorization to actually make changes to those people. So you don't have to be added to that organization or added to that project, or the only thing you can do is actually create a branch in your local and make a pull request to that. Right. But the origin and the upstream is like, that one of the hacker future, you fork that one, right, to your pickup. And then you clone yours to your local machine, right?
Yeah.
So you fork from here to here and pick your machine. So on your machine, what you're doing is, the origin URL for that repo is still set to the hacker future. That's why when you make a pull request, it's gonna go to that one instead of yours.
Unless you change it.
Unless you change it, yeah.
You all converted your future repository page at home. Why it doesn't go there? Like in the origin repository, it goes to our own.
That's a good question.
Maybe
I like that.
maybe
That's a
even
very
just
good
it's
question.
it's setting.
I don't know, you-
So I think by default, so I tried this now. I cloned the Elasticsearch repository. I did a minor change and opened the pull request. So can you see? This is what I'm targeting the pull request to be merged in. It says Elasticsearch, and then there is my own version of Elasticsearch. By default, GitHub will open the pull request to target the upstream repository. But you can choose to just make it your own version or your own copy. Yeah.
So yours is main.
So in the pull request, like after I changed it, now mine is the base I want to merge into. Okay. So moving on, because we are very short on time right now. So the last thing I wanted to show with stash is pop and apply. And so we have git stash lists. We have 3 stashes. I want to apply. I want to remove and apply the first stash. What would I see? What would I say? The top stash. What would I say? Okay, pop. So now I did pop, and then it says these changes not staged for commit. If you want to stage them for commit, do git add. Otherwise, if you want to discard them, do git restore. I want to discard. I don't want to commit. So I would say file to the text. Now git status, git stash. So I have nothing basically. And then I want to list again, but I have only 2 elements in my stash. The first one. I want to apply my second stash, but I don't want to remove it. Actually, I want to apply this. I want to pop this one. What would I say? Git stash pop. Yes, that's exactly an ID. That's stash at 1. And it says, okay, changes to be submitted. And by the way, I got the stash. This stash 1. I don't want to commit it. I don't care. So yeah, I will unstage this one and then restore it again to the original part. Okay. 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 So that's on track. Anyway, okay. So that's for stash. So moving on to a topic called cherry pick. This is a commanding Git that allows you to pick a specific commit and apply it on your local branch. So let's say we have things like this. We have the master branch. The master branch has 5 commits. And when the master branch was standing at commit C, you created a branch to your own feature branch and added commit F. But master branch now has 2 commits, D and E, and you want to bring commit E to your branch. So giving a more concrete example. So let's say Nikita, what's your name again? Julia. Nikita and Julia are working together on a feature there. So Nikita took the branch when it was at commit C, and then Julia, like being quick, finished everything and added commit D and E to the master branch. Nikita depends on commit E. He wants to get commit E from the master branch, but he does not want to get commit E. He wants to ignore commit E. So he does not want to merge master and commit branch. He just wants this commit specific. So what Nikita will do is git cherry pick and get the commit ID and add it to the feature branch.
Know the idea.
How do you think that you can know the idea?
If I could change branch.
So no, GitLog,
Yeah.
GitLog,
Also the current branch.
everything. Yes. GitLog shows everything. It will tell you which branch is standing at which commit, what's the head of the branch and stuff like that. Yeah.
And so master is the same as main.
So master was like originally software industry called the main branch or the branch that has everything master, but they moved away from the word master because it's a negative word and called it main. But they are synonyms. You can use master, main, whatever you want. Yeah. Yes. Like everyone is calling their branches main now.
So then the developer should change the name from master or property to main or property.
Maybe. That's also a possibility.
Also, like, they have a budget and we work with Nikita and we need to fix a lot of things. We do something, we did that, and I do not. And for example, like, I need to fix, like, the width of something, I need to fix. Yeah. He changes the font, and now it changes, like, the font is smaller and the text can fit in.
Screen.
But I don't know this, so I change my stuff without knowing this, and it can be wrong. I push to this, but also to push this with some unnecessary changes that I don't want. So when I finish my changes, will it override and on the main they will have this big text because I override to how I don't understand this, like, so how to
Basically, we are going to talk about this when we go to merge debates, and we also go into how to work as a team using it. Basically, what you would do, so he has his own branch, you have your own branch. You do your changes regardless of what he's doing. He does the changes regardless of what you are doing. Then once you finish it first, or ideally both of you finish it at the same time, and then merge it into the master branch. He tried to make these changes, he tried to make these changes, one of you will succeed to make this change. The other one will get, yes, the person will succeed to make this change. The other one will get a nice profit. And in this case, when we want to resolve merge conflicts, we either know how to resolve the merge conflict. So we go up and select the things that should stay, or we talk to the person and say, I have this conflict. Let's sit together and solve it.
There is no much conflict between it. It's okay, but I would work.
Change the same line. It does not know how to resolve the merge conflict and tells you the merge conflict. You have to rely on it to give have like very advanced geometry and stuff. If you do not know how to actually change it, it will not like go behind your back and kill all of your changes and bring that in. But then I can't merge it. And then give you merge conflict.
Like, for example, give like a simple example, like you're talking about. So you both, so Nikita merged his pull request and he set the weight to 80%. And you, merging it, so you set the weight to 100%. Okay, so now these branches merged. Now, when you try to make your change, you're gonna get a conflict. I said, okay, I have two weights here. One is 80, one is 100. Which one is correct? Or which one should I keep? And that's what I'm more confident.
Like, there is a command who then not big, but I thought it's meant to like, oh, this is it's big, right? It's
Yeah.
meant to be big.
No. Yeah, GIT is the one creating the conflict. No, not someone external. No. Yes.
Somebody's gonna come and say, oh, I'll take care of that for you.
No. No.
No,
No. Not sit all together, right? It's not. So ideally, everyone would be working on their own branch, right? And then when you merge to the master branch, there's like very low chance if you are working on the same feature that you don't know how to merge or which change to keep and which to discard. But in case this happens, you can in Git know who committed this line. And then you go to them and say, I have a merge conflict with this line. I think it should be like this, but you wrote it like this. Which one should we keep? Then you discuss.
Like in real life.
That's why, yeah, but that's actually why it's called conflict, because it creates conflicts in real life. Yes.
Then you walk outside and resolve it.
Yes.
Okay, last session, my own Git conflict. But I have learned to have the one before I have learned Node.js.
Now you.
Sienna solved this, and she told me that the latest or the last one for Virgin is always the conflict.
Yeah,
Usually.
yeah, exactly. The last-
Yeah, this is the motivation to work at code.
Sometimes I create conflicts with myself and then, yeah, I get a mirror and then. start to-
And you go in outside.
Yes, yeah, no, like. Yeah. Yes. So that's cherry pick. You provide like the commit ID you want to take from another branch, like whatever other branch you want to bring a commit ID into your branch, you just provide the ID and Git will bring the commit and apply the changes. Since it's applying changes in the commit, you can create commit like merge conflicts, sorry. And then it will give you a way to resolve it, basically. So
And when it comes to GitLab, how do we identify our changes? When we commit is like, is the only commit message that gives an idea that what did we do during this commit?
So you can see the author, right? So ideally, every commit has only one author. So you would like search for the author, you as an author, and then know that this is your commit, or the commit message is the more ideal part.
And the search option is just like.
There is so there are many ways that you can search when you in git log. So I would say if you say git log dash help, so it opens this one, and then if we search for filter, there are multiple ways to filter. So basically, you have an author. You can provide that as author and username as the pattern. This will bring all the commits that only you created. You can provide date filters. You can provide all types of filters. That's one way. Or if you say git log, this actually opens a command called less. So when we do it like this, it will open something exactly like, and in this case, you can filter by typing /, just one / here, and then you say your name, for example. So my username is Mahmoud Yunus, and then if I press enter, it will tell me, okay, so this is you, this is you, this is you, and these are the commits. So this is multiple ways you can filter in GitLab.
You can also,
Yeah. So there's an option called one line for git log, which will print a very concise version of the log, just with commit ID, which branch stops at this commit. So in this case, main, the head of main stops at the last commit. That's expected. And C and like the rest of the commits with commit message, commit ID.
What is the head? It is very long.
Yeah, the head basically it means the last commit on the branch. Whatever branch. So for example, if branch main stands at C, feature branch 1 stands at D. So the head of feature branch 1 is D. And the head of main is E. So when you type in, for example, you can, for example, say git show head. And what Git will understand is I am on branch main. I want to see the head of main. That means commit C. Instead of taking this ID, searching for this ID, you just put in head. And Git will translate this to the commit ID. If I do this, it will show me commit C, which is the head of branch main, and the changes that happen.
Does that like it's like from current to past? The newest one is kind of.
Yes. Yes. The head is the newest, very newest commit. Okay. So now for cherry pick, I'm on branch main, right? And then I have a git status nothing. So I want to create a branch. I will say git checkout feature cherry pick. And then now I'm on a new branch called cherry pick. And then I will create a change. Let's say I'm adding file3 text. And I'm putting cats or dogs. Yeah, let's just for the sake of being quick. So now if I do git log, no, I want the git log, the normal git log. Yes. So now if I do git log, it says a commit C main is stopping at commit C, right? And then I created another branch and I added commit E. That's the feature cherry pick branch. And it says feature cherry pick branch has all of these commits and also commit E. Yeah, exactly. Now I will check out to main and I want to bring commit E. I do git log again. It does not have E because it stops at that. So it brings all of the commits from all of the branches as long as it's not happening after the head commit. I didn't know that. So yeah. Now I have this commit E. the ID of committee, and I say git cherry pick this commit. Now I have it on main. If I do git status, if I do git log, now it says main also has committee. If I what? So merge so you cherry pick, you are bringing specific commits. Merge is just merging commits from branches, like 2 branches, and then it's like merging them together.
Main branch protect. So they do cherry pick.
Yes, as long as you are doing it in your own branch, but like don't go on. So if you go on main branch locally and you cherry pick from your own branch to the main branch, only your own main branch, the local main branch, has this commit. The remote branch does not have this commit. And if you try to push to the remote main, it will not tell you, it will give you an error because it's protected. So there's a difference between the main branch that you have locally and the main branch that you have remotely. The remote one is protected. Your local one, you can do whatever you want with your local setting.
If you have the same file, local,
Yeah.
and you get this commit,
Merge conflict.
which okay.
Yeah. Okay. So that's the topic of cherry pick. It was a quick and easy one. Now we talked about unstaging changes when we did git status, and I showed you that when git tells you what to do next, whether to commit or restore or like the git commit message. So we will not have to go through this again. Now, this is just a side topic. In the feedback, like there was this question, whether we should use Git from the terminal or Git from the desktop, or the desktop applications, the GIT2, GitHub desktop. And it really depends on you. If you can use it from the test on like any application, then go ahead and keep doing it. The way we explained it through the terminal is that you have to understand what's happening before using a desktop application, because what the desktop applications do is execute the same exact commands on the terminal, but you don't see the commands that are being executed. In this case, you can mess up things if you don't know exactly what's the desktop application executing. But this should not be the case. Like you should the developers who develop this application know what they're doing also, and they should not make it such that you will mess up your local repository if you do a git pull, for example. So in my opinion, if you are comfortable using terminal, use terminal. If you are comfortable using any of the applications that hide git from you, do that also. But you have to be able to understand. It's a matter of taste, but you have to be able to understand when things go wrong, what you should do.
That's why I recommend you to learn command line. And then you can use.
It's really easy to mess things up in Git when you will be working on a feature and then you just by mistake delete all of your changes. I have done it like 3 times. For me, at the beginning, this was very complicated. I didn't understand anything about it. When you use it with the terminal and you like read more on the internet, how to solve a specific issue that you have, you will understand it more. So if you are comfortable with the desktop applications to use them, I'd recommend using the terminal just to be able to figure out what exactly is happening. So to the next topic, that's merge versus rebase. So we are gonna start with merge.
So let's say you have a master branch or new branch that has distinct commits A, B, and C. And you have a feature branch that started when the master branch was on B, and you created the D commit. So what merge will do, that it will take like that all of the commits in your feature branch, and then creates a new commit on top of C. That's the merge between your branch and master branch, and then append this commit to master. That's it could be conflicting, of course. But the only one difference between merge and revise is that merge creates a commit to store all your changes that existed in your feature branch.
From another person or
This one?
Yes.
no, the same, the bigger after the.
So let's say anyone created a feature. This is just a commit that exists from master branch right after you started your feature branch. Because master branches should be for everyone to work on, to merge stuff in. But your feature branch is your own feature branch.
Question is under.
No, stop. No, don't go down this path. Got A, B, C,
Yeah.
and D. C and D, this is the last our commits. Yes. Why is so when you merge? Yeah. Because this F and D commit. This is the not. So I get this this like this B does not exist. Like it's yeah. Okay. But one the reason I put B here is that just to say that okay, let me fix this.
We need to show the picture right of the main. That means right that it will show CNC.
No, actually, no, he is correct, actually. Like, let's say if we made this D and then this is E, then it will be C, D plus E. I just wanted to add B here just to show that you started this branch from commit B.
But commit B already exists on this branch. Created the branch. Yeah. So when you merge, it will create, so merge will create a new commit. I call this F. Will just be a merge commit that will contain all of the changes within your branch. That's D and E. Like both changes. And also try to apply them in C. With C and create a new commit that contains D, E, and C.
Well, it makes sense to just write D and D. It's not because the D is already in the
True. The D is already in D and also like D is already in C, yes. Yeah. And D is already in D and D. It's a whole mess of crap. I just wrote it like this just to make it clear what exactly happened.
I got a question for you guys. Can you guys think of a scenario that when you try to merge that, you run into a conflict?
Yeah, of course. The big champion.
Why?
Because someone working on shift
Yeah.
from other side. And he changed also B somehow.
I think it's the reason why everybody should put in our own task. So like, I don't have to touch her task and she doesn't have to touch my task.
There's something very specific on that. That, especially when you're trying to merge D and E, there's something very specific there that you should pay attention to. It's very specific. Look at the graphic, right? And what's happening on the main branch? You're almost there. Because it's a main branch, the main branch,
Not straight to the line.
the main branch is ahead. See, when they start working on the D and E, right, the main branch went ahead. Now the main branch is at C. When you started at B,
It's like,
it's already merged. It's already merged.
it's like you work on all this version that something like that.
If like,
I
this is
think
how
we have to
you,
make.
this is how you run into a conflict. Let's say you started at B, and the main branch went ahead and have C and have some other even further ahead.
Yeah.
When you try to, if you touch any file that was added between D and C, right? If you touch any of those files that's in C, and you try to merge,
How can you touch it? So like, before
but
the
if
rules,
you put some other, you could be working on the same file, but someone else working on the same file. And then their branch was merged, now you're trying to merge yours, you're running trick conflict.
but it will show you. You like, okay,
That was my original question.
like,
But now let's say that you know, whatever you, even if you try to merge that, huh? If you could do it, you're going to merge your branch to the main branch. Or you actually pull the main branch to update the local branch. Or you
and
pull
so
it.
the conflict. Without make the.
You update your local branch, whatever the name has. You make all your commits, now you're ready to push, right? You make your commits, now you pull, you merge your origin branch to your local branch. And then you will see if you have conflict. It will show you if you have conflict. That means that you have files that already been out there on the main branch.
You're taking the-
So basically what Ricardo is mentioning is, so we looked at it from the perspective of merging this feature branch into main, but what Ricardo is saying is, what if we want to move main into the feature branch, just to bring all of the new changes that happened in main into our feature branch. So like you can merge any two branches in each other, right? So now what we are talking about is merging the feature branch into main. Am I correct? Or so we are talking about merging the feature branch into main, but what if you want to merge main into the feature branch? To bring all of the latest changes from main to avoid a merge conflict when you are merging the feature branch into main again. So
That's because the main branch is ahead. The main branch has C commit to the C that you don't have on your local branch.
yes,
Yeah.
yeah. So instead, huh? Or merge main. But if you do merge main, it will be something like this. So this one. So let's say you have another commit here that got merged into main. Let's call it F. Yeah. And F happened after C, and now you did D and E, and you want to merge master into your feature branch to bring the commits C and F. It will not be D, E, and then C and F. It will be D, E, and then another commit called J. Like this, and this J commits will be the latest changes that exist on your E commits plus the latest changes that exist on master, which is F, because we said C is in F. Ideally, I would write C plus F. This is not. This is on your local. Exactly. So it's basically you go to the branch you want to merge the other branch into, and then say git merge the branch that you want to merge. So in this case, in this specific case, we are on our feature branch, and then we say git merge main or git merge master, which will bring main or master and merge them inside our branch. No, it will create another commit that's called the merge commit and add it to your local branch.
You will not change, you're not going to do your local changes as long as you have committed. You committed all your changes first, right? And then you go and you merge the master into your local feature branch.
After that, how are you gonna push it?
How do you think you're gonna push the remote? Git push, yeah. So git push just takes the commit from your local and sends them to the remote. So if you are on your feature branch, you do and you merge master.
So you are pushing all the history.
Exactly. Exactly. Yeah. You are building, so as long as you are building new commits, like there shouldn't be a conflict. Basically.
So why you
To update so that when you open a pull request, it will not tell you you have merge conflicts.
pull request?
So
It's not the same.
when you pull from the main, you are pulling to the local main branch. You pull to the local main branch, but you are on a separate branch. That's your feature branch. So you merge your local main, the one you just pulled, into your feature branch, so that when you open a pull request, so that if you want to merge now all the changes in this J, right? In this J commit, and this J commit contain all the changes to your branch and the latest commit from the master branch. You want to merge this back to the master branch so that this J commit that has all of the changes, you want to put it back into master, right? You want to send it back into master. So you open a pull request, but in this case, your pull request will not get any merge conflicts unless someone again adds another commit to master. In this case, you have to pull it again and do the same exact thing, get a merge, commit here, open a pull request, and then you will not get any merge conflicts in this case. Yeah.
No,
So for the final project, we should always first commit, then merge the main to your own, and then merge all.
So you don't have to merge main into your own feature branch if there are no conflicts, because there might be commits on the main branch that are in totally different, totally separate files that will not conflict when you merge your feature branch into main.
It's not even like all the.
That's why I prefer rebase over merge. Yeah. And
Perfect way to go.
yeah, I definitely liked rebase more than merge, but you have to know like both, because maybe you work in a team that prefers merge over rebase.
no, I'll be student because I don't use rebates. We use merge.
Exactly. That's so that's can you like there are 3 different examples to different teams. One, like every team preferring the style they want to work with. So for me, I prefer rebase, but the only difference between merge and rebase is that merge creates a merge commit. Rebase does not create a merge commit. What happens basically in rebase is that you have the master branch or the main branch have all these 5 commits. Sorry, only commits up until T, right?
and you at commit B, you create a branch that has commit B and commit E. If you want to put your commits into the master branch and the main branch of the base, will not create a merge commit. It will take the commit B and put it in the history master branch at the end, and then commit C to the history of the master branch at the end. So it did not create one commit that has commit C and commit D. It put commit C here, it put commit E here. You could have conflicts between D and C, and you also could have conflicts between E and D in this case. Because you will need resolve conflicts in D, you might do something else. That's because, like, so it depends also on how, like, there is something called merge strategy that we will not get into. But in like the rebase first takes one by one. So maybe you change some files here that are not here. So in this case, yeah, it will like. Sorry? Like if you want to remove D, for instance, it will be easier to do that. That's one reason, but maybe the changes you will have, like you change some stuff in D, and you change totally some other stuff. And E depends on D, right? Yeah. So we base has to put D first. That's the dependency for E, and then put E again. Because E depends on E. So you can't just put E as it is. You have to put D first and then E, right?
Dependent on the D and then what is it on D and first branch, the second D adds on top. Right? Can you say
On top of E.
on top of D?
The E will be added in.
No, I mean if we add the D both.
Yeah, these are exactly the same thing.
So then we don't have any problem. It's adding in. There's nothing.
On C, yes.
So if I work on my own,
After C.
Yeah.
if I work on my own branch, can make 10 commits,
Yeah.
and they also did some commits and make to replace.
Yeah.
Everything over.
Yes. Yeah. Some people don't like rebase because of this exact issue that you mentioned, but ideally, for me, I wouldn't make a branch with 10 commits. I would make a branch with maximum 3 commits, 4 commits, and then do the rebase. In this case, it's clear. So you remember like the commit part, the like the number of commits, the discussion about the number of commits. I would go even further into splitting the changes into branches.
But it's also because right now we don't so we can do both everything by self, but if it will be huge project, so I will have small tasks, do small tasks just for one branch.
But you have to practice in the small projects first to go to the big project. So even in sharing app, I would say try to go as like as contained as possible. Like if you have a teacher working on something, try to even split this stuff into contained units.
I'm already because my last branch is in everything.
That's okay. That's a bad practice, but yeah, you like that's like you learn for the future tasks. So yeah, we want to see examples for fetch and rebase. And we have 2 more topics that's to talk about. That's fetch. What's the difference between fetch versus pull, and how to work in the final project as a team. And then we have an exercise. But should we do working lunch or should we do lunch?
We have one.
I say we don't do lunch.
I think working lunches, yeah, let's do that. So, okay, I want to show an example of merge, an example of rebase. So now we have two branches, right? Main and feature / cherry pick. We are going to work on these two branches. I am going to check out to the other branch. Git log. And both branches have commit E as the head commit. They both exist like at commit E. Nope. And now I'm on this cherry pick branch. I'm gonna implement my changes, file for the text. And we just have names. And commit. Let's call this, we had all the way up until E, so F maybe. Yeah, and then create another file with countries.
Mark, Spain.
Yeah. Yes. And now this is, so let's say this, now we are done with our feature. Let's say we went to main. I'm just simulating that someone pushed another commit into main that has file for the text, which is a file that we created. But in this case, we just have cities, maybe. New York. So then let's say this is commit H. Now, if we do git log, what happens? Yeah. If we do git checkout to our branch, do git log. Okay. So this cherry pick branch has F and G, and the main branch has commit extra that's called H. I want to merge, I want to bring this H commit into my local branch. So what will I type? Yes. And look at that, we have a conflict. It says auto merging file for the text. It didn't know what to do, didn't go behind my back and tell me I'm going to remove your changes. Conflict, there are two adds, and there are merge conflicts in file for the text. Actually, this is a nice opportunity to talk about how to resolve merge conflicts. So I go to Visual Studio, I open this source control tab. It says there are changes and there are merge changes. And then we have these merge changes saying, so you remember what's meant by head? That's the latest commit.
Yeah.
And when it says the current change, I am on branch on this branch called feature cherry pick. It means by current change, it means the head of the current branch. These are the latest changes of my branch, my cherry pick branch. And it says incoming change. This is the changes that are coming from main. The incoming changes are coming from main, and it separates them by this, equal sort of kind of line. And then it gives me on the top, do you want to accept current changes? Do you want to accept incoming changes? Or do you want to accept both changes? I'm not gonna say no to that. Okay.
The last one was compared. You can edit like this. Yes.
Compare changes, you just compare it, you can't edit it, you just know what's the difference between the two, but that's kind of redundant. Since-
Hold on to that, Tabitha.
Yeah.
Okay, this is actually simulated to see on GitHub. You know, what has been deleted, and what has been added.
Yeah,
And you cannot write anything right here.
You could just add left, right, yeah?
nope,
You
you're just reading, you're just comparing changes, but it's already happened here. Yes, so I'm gonna press, what did you say? Yes, exactly. Yes, you can even edit manually in here. You can, for example, add,
John Doe.
okay, thank you. You can add like this and then say accept both changes, and then John Doe will come with us. Yeah, okay. Yes. And then if I did git status, now after I don't know what to do, so I type in git status. It says on branch feature cherry pick. You have unmerged status. You have so fix the conflicts and then run git commit. And then it says these are unmerged status. I have to add them first before I run git commit. So I will do that. Okay. Okay, Mr. Git, I will do what you want. File for the text. Mrs. Git, actually. That's yeah, I think yeah. And then git git commit. This I will call it I. This is the commit I. And then if I do git log, I have my merge commit. That's I. Added added in my cherry branch, and that's it.
What happens if we just chose one file, not both? Is that another one was deleted or?
Yeah, it will be as if it does not exist on your local branch, but it will still be main. Okay. So
minus A and
Oh, yeah.
all message to all files.
no. So the A part. So when you go
If and all.
no, it's not editable. The A part is a little bit complicated. When you have a new file added, you have to execute git add. Okay, just for Git to keep track of the file. But if you only have changes and you don't want to say git add, you can say git commit -a m, which executes git add by default, but it does not add the untracked file. That's why I like to execute git add with dot with. Oh, but the thing with dot is if you are you have changes in the root of the repository and you are executing git add dot in a folder inside the git repository, it will not add the changes from the root of the repository. It only add the changes created in the file working directory, the file you are sending in. And then you might miss changes that you made. That's why I like to execute it also with --o, because --o just gets changes from all of the repository. No, it's only all of the changes in the current folder you are in. And that's merge. We have a commit called I that has the merge of my master, bringing master into my local branch. And now let's go back to main.
when Anna mentioned before, if we keep only one, the other zero again, make it four. Zero. So you will have it again.
No, because in the current, so if you resolve the merge conflict,
This is kind of your result.
you resolve this conflict. If you don't have to resolve it again. That's why we do this whole merging main into the current branch before we merge the branch into main again. You have to first, so if you're not working with pull request, you have to first merge the branch back into main locally and then git push main. But since you are working with pull request, you push the branch after you merge main into your local branch and then create a pull request. Pull request is basically pushing your feature branch into main, but with review first. So essentially, after you merge the pull request, what GitHub does is that it gets your repository locally on a server on GitHub and then merges your branch into the main branch. No, this doesn't have to, this has nothing to do with your local copy in this case. When you are on GitHub and you are pressing merge pull request, right? GitHub is also running on computers and servers and stuff. So on a server, GitHub clones your repository and then does this step of checking out the main and merging your branch into main instead of you doing this manually locally. If you want to do it manually locally, then you say git, I'm currently on main, and then I say git merge feature cherry pick, and then it merged my branch into main. And now I can push, but if my branch on GitHub is protected, I can't do this push. So that's how we enforce pull requests on the main or master branch. Because my branch, the repository I created, I didn't protect any branches. If it's protected, protection means you can't merge into a branch without pull request.
The request will see it. You can do it manually.
You can.
When you
Can.
did it,
Can, yes.
when he did that, it's nothing on what you wanted to find out is like he merged his local feature branch into his local main branch, right? But if the main branch is on GitHub, it's protected. Right? It doesn't do anything because you can't push the main branch anyway. Because if you try to push it, you will reject it because the main branch is. That's why it's that's why I pull request of it to avoid meeting things that could potentially break the project.
I want people to take sandwiches and continue. Actually, you know what? Let's take 5. You get sandwiches, and then when we come back, we do the exercise. Yeah. Yeah.
7 minutes.
Eat fast. Eat fast. No, not yet. We're doing the rebase. Come back. But
I want to see that. I just read it quickly on the I was listening.
yes.
Take a look at my Node.js like no rows because like when the session you help me with some.
It's always on Wednesday.
That?
Always on Wednesday.
Yeah, but
You-
it's really not
Yeah, yeah,
because
yeah,
I
yeah,
could not
yeah.
continue my.
I'm searching for the. Can you help me find like the changes that you want me to look at?
My local.
Ah. So you can always open the first one. Mark it as working progress.
You need to see, like, it's both working, the
Plane. So shall we continue? Everyone?
Yeah.
One is someone who wants to get left.
So many questions for like, iPad.
Ah, yeah. Hard to apply.
Yeah.
So to continue with with this course, we have only two more topics to cover, and we won't be able to get into the exercise, but exercise pages and the final page, how we are going to be working on the final project. So maybe next time we start with the final project, we can have just like half an hour or an hour before going into the details of the final project. We'll just do this exercise. Just getting your hands dirty with how to work in the team. So how I need to show what's like how the rebase happens. So I'm on branch main. We have I'm on branch main. If we do git log, we have all of the commits existing on main all the way up until I. I'm just gonna add a new commit. I'm gonna add England to the list of countries. Holland. Oh, Egypt. Yeah. Yes. So I am creating another commit. I'm gonna call it, so we stopped at I. I'm gonna call it J. That's our new commit. That's our main. And if we check out to feature branch, our feature branch, we do git log. We are only standing at I, right? And then what since I'm on my feature branch, I'm just gonna add more cities. Now we have commit K on the feature branch. Let's just add another commit. Watermelon, orange. So now we have, so now the situation is like this. On main, our last commit is J that does not exist on our feature branch. And on our feature branch, we don't have J, but we have two commits called K and L. And what we want to do is to rebase the commits inside of our feature branch from main. So what we effectively want to do is to bring the commit H that doesn't exist in our feature branch, right, into our feature branch. So we are on the feature branch, we say git rebase and just say main. We want to rebase our branch on top of main. So basically, if we do that and we do git log, so you can see the commit J, sorry, it was J, not H. The commit J from main exists on our feature branch. And it applied K and L after commit J, right? Because commit J was made first, and then commit K, then commit L. That means that if like Git, when it's doing rebase, it respects the order of the commit, which was done first, and then applies the commit. And then we go to main. What do you think will happen if we replace main on top of the feature branch that we have? We don't have K and L on main. So it will bring K and L from our feature branch and put it in main in the right order after commit J, right?
File before, right? You don't say, even if we commit nothing will be added, right? Or it's done like-
So it works with commits. So if you have the file committed, then that's it.
I mean, file control S, you don't press control S. It's still-
But that's that if you don't press Control S, it will not commit anything anyway. Right? Mhm.
Great. And it's Copenhagen. Don't say the file, but
It will not see the file. It will not see the changes. So yeah, you have to save the file and then add it and then commit it, and then you can do rebase and reverse. Yeah. You wanted to say something?
But the rebase gate to the main is just as an example, right? Because ideally we would make a pull request.
Yeah, I'm just showing it with different branches locally, but the ideal case is you would create a pull request to put stuff into main. I'm just like, think of main as like two different branches, any two students working on two different branches, and they want to rebase their branches on top of each other. Yeah. Yeah. You should be on the branch you want to like rebase to. Yeah. So now we have the commits in order. Notice that it did not create an extra commit for the like like what happened with the merge. So merge creates an extra commit for the merge changes. Rebase does not create an extra commit, but takes the commit and just place them in order, right? So there is one more topic that we want to get into, that's called interactive rebase. Interactive rebase. Interactive rebase allows you to go to a specific commit, edit the changes, and amend the changes to the commit. So that's this means this is basically the solution to the scenario if you have a component that you committed and you have another component that you committed and you want to go back to the first component to do some changes. And the way we would do that, I will just check out to the feature. No, not like cherry pick. It's cherry pick gets a commit from another branch and puts it into your branch, right? Huh?
You can edit as well.
I'm sorry, I can't hear you.
This time you can edit as well.
With cherry pick, no, you can't, because it will bring the commit and put it. It will not give you a chance to edit. Let's create a merge conflict. But we don't want to, like, if there's no merge conflict and we want to edit the commits, then this is like what we go to. So I'm just gonna do two more changes. Maybe, and just adding these two countries. And now I created two commits, M and N. And if I do git log, these two commits exist on my feature branch. They don't exist on main, so I don't care. I want to get the latest commits from main, or I just want to do interactive rebase. I would say git rebase and then -i. -i here means interactive. And then say the branch that I'm rebasing against, which is main. Sorry. And then it opens this nice editor that tells me these two commits don't exist on main. These two commits only exist in my branch, but don't exist on main. And then so I did the commit M first, and then did commit N, right? I want to modify commit N. If you would read all of this, you would find exactly what you can do with interactive rebase. So for example, pick means pick this commit and keep it. Reward that is the same as commit, but gives you a chance to modify the commit message, only the commit message. Edit uses the commit, but stops the rebase after it applies this commit to give you a chance to modify the changes, which is what we want to do in this case. So when I said rebase, picks commits and applies them in order, right? So it will get commit M, apply it, and then stop. It will not apply commit N until I tell it apply or continue the rebase to apply commit M. And in this case, it will give me a chance to modify commit M, amend the changes that I have in commit M, and then recommit with the new changes, and then go and continue to commit N. Is this clear? Confusing? Okay, silences are yes for me. Okay. So we have like even more commands that we can use, but we will just stop at edit. If you want, you can, like, this is left as an exercise if you want to continue reading what do the other commands do. But all of these are commands that you can use with the interactive rebase.
And should see all these commands, what did you?
I just type git rebase, then -i, which is the interactive part, and then the branch that I'm rebasing against. And then I want to edit commit M. So that's what I will type. I changed the pick, removed it, and type edit. And then I will save. I will exit and save by writing and quitting, like I do here. And then if you read here, it says stop at commit M. I didn't apply commit M yet. You can now amend the commit with git commit dash amend. Once you are satisfied with your changes, type git rebase dash continue. So in commit M, if I do git status, it will tell me the same exact thing. There is an interactive rebase in progress, and the last commit done is commit M. Next command to do, that's the next command that will be applied after you say git rebase continue, which is we are gonna pick commit N and apply it. So it says also you are currently editing a commit while rebasing. So if you have changes to amend, you say git commit dash amend, or and then afterwards you say git rebase dash continue. There's also git rebase dash abort if you want to abort the interactive rebase. We don't want to continue with this rebase. Let's abort it. And what I want to amend more countries. Any more countries to add? Portugal, Argentina. So now I have my changes. I press Control Save, Control S. And if I press git status, again, it says you have modified file 5. If you want to add it, you just do git add. So I'm gonna do git add dash all, or let's be more specific, git add file 5 the text. And then I do git status. These are staged commits. I want to amend the current commit. I would say git commit dash amend. And then it opens this editor for me to modify the commit message if I want to. So I will just modify this, say git, this is commit M, amended. And exit. And then if I do git status, now I have updated the commit, but I'm still inside the interactive rebase. I want to continue the interactive rebase to apply commit N. I just say git rebase continue. Notice that after you edit commit M, if you want to apply commit N, you might run into merge conflict again. And in this case, you would resolve the merge conflict, do git add, and then git commit dash amend. Actually, no, git rebase dash continue. Continue takes continues the rebase, which is take the rest of the commits and applies them one by one. Okay. The what? Now, when the rebase ends, you will so when I said git rebase continue, that successfully rebased and updated this branch. Now we are outside the rebase. If we want to make sure we are outside the rebase, we just type git status, and it says nothing like print here. It's print that we are inside the rebase, right? Now with git status, it says we are on branch and nothing to commit. Everything's clean. Now we are outside the rebase, and now we are working normal. On daily basis. On daily basis. So you create a pull request for your branch, right? For my daily work, I create a pull request for every commit. So if I have a pull request out and I want to, someone left some comments and I want to modify I want to update the pull request, I use interactive rebase to go back to the commit that this pull request is tied to, do the changes, do git push, and then continue the rebase to go back to the latest commit that I was working on. That's what that's exactly what I do with interactive rebase. But instead, it's just because for me, I do a pull request per commit, not per branch. That's why I use interactive rebase on daily basis. Yeah, but that's not the usual case in normal companies. Like if you are using GitHub, we don't use GitHub for now. If you are using GitHub, you work with branches, and then for every branch you create a pull request. Yeah, some other applications. There are different applications other than GitHub that do this. Like so there is a difference between the remote and the local, right? So Git is just the program that manages the repository locally and also like remotely. You can have, for example, GitHub or GitLab or any other source control providers like Bitbucket to create your remote repositories on. You might need interactive rebase or you might not need interactive rebase. It depends on like what you do, but interactive rebase is tied to Git, not GitHub or GitLab or Bitbucket. You get the idea? It's a command in the software, in the Git software itself that you can use depending on your use case. Okay. Now we are done with this. There are only 2 topics left. That's what's the difference between, this is a question in the feedback. What's the difference between fetch and pull? So when you have commits on the remote, for example, you are on main, right? And then you have commits on the remote part on main, remote main that don't exist on your local main. So you do git pull. So git pull brings the commit to your local file system and applies them. Git fetch just brings the commits, does not apply them. So it tells you that the remote part has commit E and E and F that don't exist on your local part, but it does not actually get commit D and E and F to your local file system. So git fetch is, so git pull basically executes git fetch and git pull. Just in case you want to know what that are coming to your local branch that are different.
Anywhere somebody already approved, it's changed.
Depends on what you want to do. Maybe you just want to know what it is, but you don't want to bring it. You just don't want to bring it. You know, you want to know what exactly is the difference between the current. Huh? Yeah, exactly.
Like before.
Yeah. But not actually have the commits looking for. And the final topic we are talking about, and this exercise we will do next time, we won't do right now, but how are we going to work as a team in the final project? So normally in the final project, you will be split into teams of 4 or 3, depending on the depending on how Renee and like the management, project management. Yes. Yeah. And normally, like the final project, you will get, every team will get tasks to implement. So let's say Nikita and Julia and Anastasia and Anton are in a team and they are working on a specific task. Everyone, like it's a specific feature that's split into multiple tasks, but everyone has got his own task, and we have the main branch.
So everyone will create his own branch from the main branch. Do the changes regardless of what the other person is doing. Just do the changes they should do. And then commit and push. And then create a pull request. The pull request will be reviewed by your teammates. So if Peter has a pull request, it will be reviewed by Julia and Station Anton and one of the mentors. And then when the pull request is being located, is mergeable, will be merged into me. Julia has another pull request that got reviewed by Anton and Station by Peter and Station Anton. And one of the mentors started creating a merge conflict because of Peter changed the same file that Julia is changing. So it's on Julia to solve the merge conflict. Yeah. So, yeah, when you're resolving a merge conflict, you can just, if you know what you are doing or you know the scope of the feature, this will be the change that you do. And that's fine. Go ahead and resolve the merge conflict on your own. Otherwise, bring your teammates, sit together, do peer programming or peer debugging, resolve the merge conflict, and push.
From the name of team branch and the team branch, our branch.
No, you're not finished with your team and then the feature. From me. If you noticed when I was creating my feature branch, this one, I said feature, bless you, feature slash character, right? When I create my branches at work, my username goes here. So it will be in units slash the task number I'm working on. If we are going to use Jira as the task management, I don't know what exactly we are going to do, but every task
Using Trello.
Trello. Every task also has a task ID or at least a task name. So you create username slash task, and then you do the changes that are required in the task, then open a pull request. You run into merge conflicts, you know what to do.
Always remember, a new branch is created from main.
Yes. Yes.
That's great.
Yes. If you if you open a pull request and the pull request tells you this pull request will not be merged because of merge conflicts, which GitHub will do, you have to do the merge or rebase from main to your feature branch, and then do a git push again to update the pull request. Okay, and yeah, I think that concludes all of the topics I wanted to go through an exercise. What's unmerge? Because if you do a merge, you create a commit, right? And we know how to unmerge. So unmerge basically is undoing the merge.
Okay. And what that is file, they can't index and like removing something.
So let's say no, there's not remove from if you revert the commit, you create another commit. And then you have to push this commit. That's why I took every day.
I don't think it can be.
Revert or revert, and if you merge the commit into main without reviewing, it shouldn't happen. You have to revert the commit and then push again. And then you can, if you want to bring, so when you revert the commit, you will be embeds, right? Yeah. You want to bring your changes again, what you do? You cherry pick the original commit that you reverted just to bring it locally, and of course you specify no commit. Continue your changes, and then commit again, do a pull request this time. So it's merging that state. Not do that. Yeah. Okay. So yeah, that's it. We don't have enough time for this exercise. We still have 10 minutes. Oh wow. Yeah. Yes. Is there anybody who has questions from the survey that were not answered? Maybe.
Maybe. Let's
That were not covered. Oh.
yes. So any questions in this survey that were not answered? So how to undo, change, run commit, that's revert and reset, right? How to store deleted commits. So if you delete, so you can't really delete a commit, because as I said, you can't go to a commit in the timeline and then just remove this commit. You have to either reset or revert. If you do reset with a hard option, your commit is gone. Yeah. I would also say that's not completely true. There is a command in Git called reflog, but I will, like, you read about reflog. You go and read about reflog and how to use it. If you find it hard to understand what reflog is, please join the Wednesday online study group. We can go through the reflog command. Yeah, and is it the same using the terminal as GitHub or any other application? That one we answered. Is it possible to delete changes that were committed? We have responded with revert and reset, and you have also interactive rebase. And how to work on team, we just talked about this. So merge, we covered. Why do we do pull requests from GitHub? Can anyone answer that? So updates, and also to provide the chance for others to review my changes, to make sure my changes are okay, are sane, follow the team standards. Yeah. So resolve conflicts. Any other issues with resolving conflicts? Okay. What's Git restore? That's the one we read about in Git status. To undo the changes, Git reset we covered. Undo changes we also covered. Right? We talked about Anastasia today. So, yeah. Yeah. So Julia, we covered this part. Yeah. Yeah, it's there's no, like, the question itself, like, really doesn't make sense.
So for example, under my name, that's the same.
No, you have to clone the hacker feature report with the changes. You cannot cherry pick across repositories.
Actually, there is a way for it. There's a way to, but it's a long way. Be sure that you have the change back on the project at the same time, so you can get the changes. That's the very, and save it someplace. Once again,
Yeah.
it's a long.
So just finish.
So there is the homework also that will be posted on the channel. Yeah. It's also on the GitHub Git2 repository.
Okay. Yes.
Yeah.
Okay. So that's remember here during the video.